prepared for the snow. I experienced a couple large snowstorms in the past. After we moved to Maryland, which was fairly warm, back in 2009 and maybe 2012, they had 30-inch snows, which for that area was pretty much devastating. Closed everything for a week. And they just didn't have the capacity to deal with it. Nobody had snow tires, people didn't have shovels, people don't hardly have winter clothes. It just doesn't get that cold. So, around here it'll be a lot of snow with forecast, but they deal with it pretty well. Still, it could be a lot. So we'll see. Could be fun, could be fun. So anyway, to do studies in statistics, we need data, and we need some way to gather the data. And we talked about surveys last time as a way you often get data from a population. Another big way in biology, biological sciences, and other things are experiments, right? So we want to understand some of the key characteristics of experiments, give it an idea about kind of the steps that would be taken in a general sense in doing experiments, and what's some value of randomization. What does it really get you by having some random assignment to treatments, right? So on the handout, pages that we'll look at. So in experiments, the goal that we have is to compare two or possibly more treatments. Right? We want to know if taking drug A or taking drug B, which one will have the benefit. They developed a new drug. Is it better than the old one? Is there a comparison? So we hope to establish causation, saying by taking a certain drug or behaving a certain way or doing something, that it will necessarily, on average, have a different impact. Right? And a key element of being able to assess that and claim that something causes something else is randomization. Right? So if you can randomize these patients to treatment groups, the randomization, the key thing that it does is avoid a selection bias. Right? So if there's two drugs available and a primary care physician is evaluating a patient and decides, well, I think you would do better on this drug. Right? And for another patient, says, I think you would be better on this one. Right? There's not only the differences in the drugs, right, that are being applied, right, but difference possibly in the groups that are receiving them. Right? If there's a new experimental drug and a physician doesn't want to put patients that are older, more frail, or poorer health on that new drug, and instead we tend to put them on the more standard one. Right? And then for the individuals who are not such bad case, maybe have kind of more adventuresome personality or something, and tends to put them on the new one, right? And you see a difference between the groups, either positive or negative. Right? It's impossible to tell or convince somebody that it's due to the drug, right? Because the groups were imbalanced and different in fundamental ways related to their health. Right? The fact that there's a difference after a treatment period can't really be ascribed only to that drug. And that's where randomization comes in. Right? If the groups were fairly distributed, so that there's no real difference between the groups going in, and the only difference between them should be, on average, right, which drug they're taking, then people tend to believe that